All right, Rob. Well, thanks for being here today. I appreciate your time.
Sure.
I know you said you were in you were in
New Orleans
last week.
Yeah, the whole week.
For the whole week.
Yeah.
And you're always traveling. You're always going somewhere.
It seems that way lately, yeah.
So now we're talking about where we would like to have homes to retire in.
Yeah.
Let me start at the beginning. I like to start at the beginning when we
All
do
right.
these. Tell me, where were you born? Where'd you grow up?
I grew up in northeastern Pennsylvania, up in the coal mining, what used to be the coal mining region of northeastern Pennsylvania. So most people have heard of Scranton now because of that show, The Office. Years ago I would say Scranton and people were like, what?
Yeah.
And then after that show, which I didn't really watch when it was on the air, I just didn't, I'd say Scranton and everybody'd go, The Office? And I'd think, there's offices there. Yeah. And then I realized.
It did become famous for
Yeah,
that.
so about 20 miles north of Scranton, up near the New York State border, a little town called Forest City. And it was actually the end of as the anthracite coal came up this Lackawanna River Valley, it was the end. Like it just stopped there.
Really?
And so it was an old coal mining town. And the forest part of the name, Forest City, is because there were really old growth. And so they got a lot of timber there for shoring up the mines.
Oh.
But yeah, it really was, as a kid you don't appreciate it, but it was a great place to grow up.
I
Right?
bet.
To be out playing around and we were in the woods all the time. And,
I'm always curious because when I drive around, like we have a son that lives in Delaware, so we'll drive occasionally to Delaware to see them. And you go through these small towns and you just think, why do people live here?
Yeah, what was here?
Yeah,
right?
so what did your dad do that had
when I was young, like 10 or something, he worked, at a factory. I think he actually worked up in Binghamton, New York. I can't think of the name of the Hendrix or something like that. They made components for something. But probably I would say the most was for us right in town, a small tire shop where they, worked on cars and changed tires. And it was actually owned by the brothers of my grandfather. And it's really turned into a huge company. We had no stake in it, though. His brother, like my grandfather's brothers did it. And my grandfather was a junk man, right? So there's my fortune, right? But
I'm thinking of Sanford and Son.
Yeah. So
you may not be old enough to remember.
No, I remember that. We were just talking about that at the meeting I was at. And it's called Coast Tire and Muffler. There's a plug, right? A free advertisement. But they're all through that whole area. And then he worked there. So he, in a way, was related, but he just happened to work there. And then my mom worked at the local newspaper, came out once a week.
Really?
Tiny little town. And then at the local bank. And then they retired there.
So how far were you from New York City?
Oh, we never went there.
Well, I didn't ask you.
No, I know. That's a good question. Probably as the crow flies, 130 miles, maybe. It's not far. No. Right at in the Poconos. If you ever heard of that area, the Pocono Mountains, right? And as I grew up,
beautiful.
Oh yeah, where I grew up, it was called the Endless Mountains. It's just nonstop mountains, not Utah mountains like we were talking about or Colorado, but they just roll forever. And but we never went over that way. But it was funny, as time went on, I noticed how the Poconos kept creeping west. So like where I grew up, the Poconos, they were ways away.
Right.
But by the time I was moved out and stuff, the Poconos were like 2 mountains away. Like people try to claim that because of the popularity of it and building cabins and stuff.
So when you were growing up, at what point in your life do you think, I think I'm going to go to college? Because, people like you and I that grew up with parents who didn't go to college, it wasn't really expected of us.
Yeah, no, so my brother was the smart one of us, right? He
Older or younger?
11 months older,
really?
Actually. Yeah, he turned 60 today, I think.
Happy birthday, Robert.
And so he's 11 months older. That's referred to as Irish twins, right?
Yes, I have heard that term.
Yeah, and but at any rate, so he was going to go, and but I started running heavy equipment like John Deere dozers and stuff, working for a local contractor, which I would never trade because I learned so much about doing that kind of work,
right?
And hard work. And I thought that was the coolest thing, And then my dad was kind of like, well, are you going to try anything different, or go to school? I was like, no, I think I'm doing good. And he's like, 20, 30 years from now, you probably won't be saying that when you're the guy in the ditch still or whatever. It's a noble profession, but it is hard work.
Well, especially every time we do something in the house, right? The carpenters, you'll see them, and I just say to my wife, that's not an old man's job.
No, it's hard.
They're crawling around on their knees or doing whatever.
Yeah,
right?
what's left of their knees.
Yes.
Right? And so he was the one really. His thing was, well, you should go somewhere. Why don't you give it a shot? So my brother was at the University of Pennsylvania, right, in Philly. And right next door was Drexel, which was a strong engineering school in the state. Right. And I had gone to Philly to visit him, and it was neat. So I applied to Drexel. I got in, had loans and all that kind of stuff. And I actually started electrical engineering.
The Drexel Dragons, right? Drexel
Dragons, yeah. The thing on the, my brother-in-law used to sell these kind of shirts, and they didn't have a football team. And it said Drexel football, no wins, no losses, no team, Similar to another university, maybe football's not doing well. But at any rate, and I really struggled as a freshman.
So you started in electrical engineering?
Started electrical, and then I took statics, right? And right? And that's where you get forces and beams and stuff. And that clicked, because I could see it, right?
Yeah.
Ones and zeros, I couldn't see. And I thought electrical because I liked lights and wiring and, tinkering around, but that wasn't electrical engineering. And the professor said, one of the it's probably old Pennsylvania Railroad or something, ran through right near campus, basically at the edge of campus, up on a big elevated steel structure. And he's like, so if you go out there, you'll see a pin in the roller, like what we were talking about. And I was like, huh. So I go out, walk down the street, and sure enough, and there was a train going over it. And that was it. That's when I wanted to do bridges. I was just like, that is cool. I can see that. And so then I was very interested, right? Before that, it was like, I was struggling with classes and didn't. But once I kind of got the structural side and switched into civil, then I really, really enjoyed it.
So is it safe to say you were another one of those people who didn't know what you wanted to be as you were growing up? You didn't have a plan?
I didn't have a plan. I knew I wanted to build something, like I knew, but
right.
Like in what way?
But you could do that as a contractor, right?
Exactly, yeah, exactly. And I thought, like grad school, no way, right?
I didn't even know what that was.
Yeah, I mean, that's the really smart people doing that. And then so I got a job at a company that they've been bought out. Griner Engineering was the name of it. Did some really noteworthy big bridges in the East in particular. And worked there, but then I was taking courses at night. And I started to realize, like, wow, this is cool. There's a lot I don't know. And I decided to go back to school to get a master's full-time. And that's when I ended up at Lehigh, and that's a neat story. But and then really enjoyed that, and then they, made the offer about, well, would you want to stay for a PhD? Which, again, you have to go back, right? I wasn't going to do any.
Yeah, I wasn't going to
college. I wasn't even going
college.
to finish the bachelor's, right? I was going to do that because my dad asked me to do it. And then, then he was like, I wanted you to go to school. I wanted you to get out at some point, right?
So your parents were like mine. They thought, this kid's never getting out of
yeah,
school.
right. They had to convince me to go, and then I wouldn't leave. So, and then that was a great experience. I got to work with really good people over there. And then worked for a while there as a research engineer and came to Purdue in 2005. And so going into my 21st year here.
Been a long time, hasn't it?
It has, right? I mean, yeah.
Some days make it longer than others,
Yeah,
right?
yeah.
Some days do seem long.
Yeah.
Well, that's good. So, so you might have ruined my question, which was this, Rob, why bridges?
Yeah, that was it. They move, I could see them, I could relate to it, and I like that, the structure's exposed, right? So, we're in a building, right? For the most part, buildings just kind of sit here.
Right.
Right? They're concealed from the environment, right? We don't.
Well, the inside is.
The inside, right? But they don't have like the exposure like bridges do with salt and traffic and impact and stuff generally, right?
Yeah. The weather doesn't like get on the steel or anything.
Yeah, not as much, right? I guess outdoors it can if it's an exposed steel structure. But, if you have an earthquake, there's an event, obviously. But every day bridges are getting beat up. And that's what kind of drew me into the area of fatigue and fracture, was that's the live part, right? The constant load, unload. And
so, you finished at Drexel and went to work for an engineering company that was doing
correct.
bridges, right?
Yeah. So I was doing inspection, design, that kind of stuff.
So when you went to Lehigh, was the draw to go to graduate school, or was you were drawn then towards the fatigue and fracture?
Fatigue and fracture. So Lehigh was the home of fatigue and fracture, right? Everything that's in our AASHTO specifications back in the 70s that came in about how to do fatigue, a lot of the fracture control stuff, and there were other people, at other places, but But Lehigh was, like there was so much steel work that came out of Lehigh because it was in Bethlehem, Pennsylvania, right? So it was in the shadows of Bethlehem Steel, right? So they did a lot at Lehigh, and so much so actually that, it's referred to as the Lehigh Mafia, right? On the steel side, right? There were so many people coming out of that program. And for a tiny little program, the impact that that place had.
Yeah, Lehigh's not a big school.
No,
right?
not exactly. I think at the time when I finished, like undergrad and grad, it was like 6,800 or something, right? And so the impact that they had, again, being in the shadows of Bethlehem, or the Steel, as everybody called it, right? But I knew their reputation in fatigue and fracture. And because the things I would be reading, because I was interested in that, were all by these John Fisher, Ben Yen, these kinds of guys. And the funny part of it, I said there was a funny story, was there was a professor, Dave Fielding. He was teaching a course at Drexel in steel, and he did his PhD at Lehigh. And that was all I knew. I didn't know much about that. And so one day after class, and everything was at night. They were night classes. It was geared towards professionals. And I went up to him and I said, how are you ever going to talk anything about fatigue and fracture here? He's like, nah, well, maybe a lecture. He's like, but if you want to know about that, you need to go to Lehigh. And I'm thinking like, well, yeah, but it's Lehigh, nothing against Drexel, but, for that topic, it was, And I said, yeah, I don't know. And he's like, you should call Ben Yen, one of the professors there.
Just call him cold
Just call him. And I'm like, okay, there's John and Ben. It's like the president and the vice president, right? Like, yeah. He said, no, tell him Dave told you to call. All right, so I get the nerve up like 2 weeks later, I call. And I can't remember if I got him or he called me back. And, Asian gentleman, but the funny, he just made you feel like you could do anything. Just an encouraging guy, right? And I told him, I said, well, Dave Fielding told me to call you. It's like, Dave? Oh, how's Davey doing? Turns out that he was the godfather of Dave's kids, because it was the Lehigh Mafia, right? They're all connected.
They're all connected.
So as soon as I said I knew Dave, and Dave recommended, he's like, well, when do you want to come up for a visit? Okay, so then I come up for a visit. And they had this new NCHRP project starting, and I got to meet some folks there, Mark Kaczynski, Robert Dexter, who were working on that. And long story short, they offered me something, but I had to start in January of '94, and this is like late November.
Ooh.
And it was an incredible opportunity, but so then I gave my 2 weeks notice. I don't even know if I could give them full 2 weeks or something like that, but it was all okay, And so, things just opened up great. I mean, it was just a great opportunity at Lehigh. And it was all in fatigue and stuff with field testing and the work. My master's work is in the AASHTO code. And that was always that. And that's what really got me too then on the research side. John's work, Ben's work, Robert Dexter I worked with, they were very big on doing great research. But the research always would have impact. Right? And it wasn't just pumping out journal papers, and that's fine, I guess. But, it's when it has impact. When you can, because as you know, to get something in a code or people to use goes through a lot more review than a journal paper.
Yes.
And that's been something that I've tried to instill that into my students is like, do cool stuff and do good work and all that. But do something that somebody might use or have some impact. Have your fun, your little blue sky thing over here. But if you can anchor yourself in solving problems, you'll always get the phone call because they trust you.
Yeah, which brings me to the fact that you're kind of one of the guys they call whenever there's a steel bridge problem in the U.S., aren't you?
Occasionally, it seems.
No, you were called when I-35W had a problem, right?
I was out in southern Utah, actually.
In southern Utah.
Yeah, on vacation.
Yeah.
I got a call on that one and a couple others.
Well, I mean, the one when they found the problem at Sherman Minton, right? They called you.
Yeah, we closed it that one Friday afternoon.
Well, I could ask you questions about what's the worst thing you've ever seen. You thought, oh my gosh, we got to close this now. But I don't want you to name names.
No. It's a good question. I'll tell you, I think sometimes the owners might get a little bit of a bad rap with something. There's not an owner in the country or an inspector who is, I think, nobody wants to be the person who had that come down on their watch. And I knew the people who've had these serious issues on their watch, and I've seen them in tears because they were, how did I miss it, right? Like 35W, everybody would have missed it. Everybody did miss it, right? And I knew that bridge engineer well. He was a gentleman, a great guy. And he was just like, how did I miss it? It's like, well, you would have had to do analysis that didn't exist, right? Kind of thing.
Right.
So I don't think anybody wants that to happen. In terms of things that are bad, there's not a lot of that, in all honesty. I think they're usually more the other way. In fact, I kind of find myself on a lot of calls saying, like, I'm not trying to be cavalier, but you don't need to close those lanes, because it's a risk balance, right? You kill people because you back up traffic, I-65, right? And so if you're going to close a lane, you better have a really good reason to close a lane on an interstate, because you're probably going to kill somebody in a backup or have a serious accident. And where the structure, again, if you have to, you have to. But I find that more often than not, there's almost the overreaction, and which is, they're trying to do the best they can.
Well, but, if you're a state DOT or something, you have to be conservative.
Yeah,
right?
yeah. And taking the risk, there's no incentive to take the risk, like if you're, in private industry or something like that. But,
well, even then, I tell people, look, as civil engineers, we tend to be very conservative when we work, because we do things that if something fails, somebody could get hurt.
Yeah, and there's no doubt on that. I mean, I was on a call on Friday. I got a call from an got when I was at the airport in wherever I was connected, and they had an impact. And, hey, got to close lanes and this and that. And I said, well, send me some information. And, I looked at it and I was like, okay, what all do you have closed? And it was a lane and a shoulder. And I said, and they said, yeah, traffic's terrible on this interstate right now because of this. And I said, I'd open the lane. The girder's not under the lane. It's a fascia girder because that's what gets hit. If you want to keep the shoulder closed, I've seen a lot worse kind of thing. Right. There's 8 girders in the, and that's why I said, I'm not taking that risk directly, but I would have no issue with opening that lane, right? And the other side of that coin always is, and again, not to be cavalier with it, but a lot of times I find when people detect a problem, they really believe it happened the night before. Like they just found it, right? And it's like, yeah, that's been there for about a year. You can just tell or whatever. So just because you found it doesn't mean it's any more likely to get worse. Right? It doesn't know you found it. And so, again, not trying to be cavalier, but it's just that balance of risk. And I've learned that over the years on a major, not a major, but a big fracture that occurred on a bridge over in Pennsylvania, where my initial thought was, hey, well, we should probably do this or that. And then sitting in the room with the people who do like a Darcy Bullock, right? Like a traffic person saying, well, how certain are you that could be bad? Because, and then they lay it out all the ADT and the local roads and the bus stops and you're diverting trucks. And they're like, oh, not that certain, They were more certain there'd be a big problem if you close those lanes, so.
You and I both worked around a lot of DOTs during our careers.
Yeah, you know that, right? You're around that.
The thing that I've always, DOTs get a bad rap from the public because the only thing they see are road closures, right? Yep. Every state has the joke about the cones popping up in the summertime and blah, blah, blah. Yeah. My experience with DOT people is that they're really pretty good at what they do.
Oh, yeah.
And they're very public conscious of making sure people are safe.
No, that's what I'm saying. So when you say, like, what's the worst thing, it usually isn't, they try to catch it. And they're out there inspecting and trying to do the best they can with very limited resources that they don't have control over, right? And I think the other thing you have to keep in mind with it is, I'm this narrow-minded fatigue and fracture, right? So I have my little area of expertise. But you have to realize they're dealing with timber, culverts, concrete, pre-stressed concrete, riveted steel. Like, what they have to be, fire damage, impact damage, right? Scour. Like, what they have to worry about in the inventory, next time for your viewers, like if you're driving around the state, count the different types of just bridges you see, let alone all the ones you don't see that you're just going over, right? All of that stuff. Then all the fabrication and construction. So they have to be so wide, it's not easy. They can't be super deep in an area. And where I was going is that, and that is one thing I enjoy, is that, you have your area, I have my area, different people. So I have the luxury to be this narrow guy in my little area, and it's nice when you can help somebody. Now, I'm not going to talk to them about concrete because that's not my area. There's somebody else who can help them. But it's nice to be able to get that call and then just say, yeah, well, we can help you out. And that's like S-BRITE, right? That's one of the big fun things we do is help out the owners.
Well, I've talked about this a little bit before, and you mentioned S-BRITE. This idea or the fact that when you go out and inspect a bridge, because bridges are inspected on schedule, right?
Yep.
And you go out and inspect a steel bridge, it's not always obvious
No.
The crack is not always easy to find. It's
No, they're
not
very difficult
It's not
usually,
always
yeah.
there.
Yeah.
So you are the director of the Center for Aging Infrastructure, right?
Yeah. Yeah.
And the corollary to that, or I guess is kind of as part of that, is the S-BRITE Center, right?
Yeah,
Which I can never remember what the acronym
No,
stands
that's fine.
for.
So CAI, Center for Aging Infrastructure, is kind of like this very unique facility. You're very familiar with it, that we have here at Purdue, the 20-acre right, outdoor living lab, or whatever you want to call it. Then S-BRITE is a user. So S-BRITE is Steel Bridge Research, Inspection, Training, and Education, or engineering, depends what mood I'm in and who I'm talking to, right?
Who are you talking to?
But yeah, and so we use that facility, right? So like next week, I was saying I'm going to be out. We'll be in South Dakota doing training for 3 days, right? So that's one of the things we do. But it's kind of an idea that I've noticed that this idea, with the tighter and tighter budgets, and infrastructure ages every day.
Right.
If you think about what you had to worry about in the interstate era, everything was pretty new. It's not the case anymore.
Everything's pretty old today.
Everything's pretty old today, right? And so what you have is then a workforce on the DOT side who weren't even around when a lot of the issues that you have today were first discovered. So they kind of get forgotten, right? You repeat the same thing. They have less people, less expert. They used to have the welding expert, the coating expert, if I'm just talking steel, right, the bolting. They don't have that anymore. They don't have that kind of staff, right? They've just, through attrition and just cutting budgets. And so then you're doomed to repeat problems or not recognize something could be a problem, okay? Sherman-Minton is a perfect example of that.
Right.
And Sherman-Minton is what led to S-BRITE, was the fact that there was an issue with the type of steel that was welded and hydrogen cracking, and it just wasn't understood that that could be a big problem if left alone. And INDOT was I give them credit. They were very forthright, like, we don't want this to happen again, closing an interstate Friday night type of thing. What do we need to do? And so I said, well, you got some training. I said, and then that's where I first pitched it to INDOT, and they chewed on it and were like, this is a neat idea.
So S-BRITE, so INDOT is a big proponent of S-BRITE.
Oh,
but
yeah,
you
yeah.
have several other DOTs.
We have, I think, and I think we're about 27 states right now.
Yeah.
And so what they do is they all pay in like a yearly fee. There's different levels and different things, and it's I would say states can jump in or jump out. No one's ever jumped out. Everybody has stayed over the years.
I'll just knock on wood for you.
And so what we do is we provide specialized training, higher than the NHI stuff, I would say.
Right.
We provide, we'll do research, we'll talk to the states, we take some of that money and put it into a piggy bank, and kind of say, okay, what do we all think we need to do? We just did a little project I can share. We can do special subtasks. So a certain state can say, I really need to learn about this. Minnesota had us do a special set of tests for them, right? So they can do it direct that way. But I think the big one that they like the most, and they feel that they really get their money's worth for, is what we call the DEN, the Distributed Expertise Network, right? Mm-hmm. Because, again, they don't have the bolting expert anymore, right? But I do. I can go to somebody,
right.
Stability expert, or if I can go to call Varma, right? He's our fire, right? So if they have a truck impact with a fire and there's something that's uncertain, and they don't have and we're unbiased. I don't have a dog in the race.
No, you're just
right?
telling them the truth.
We're just telling them the truth. And so if they're getting a girder fabricated by, John Haddock Fabricating, and they're like, hey, when they made this weld, this happened, and should we reject the girder? It's like, no, you can grind that, and do this and this, and you're good. Why waste all that time, schedule it right? The girder's going to be fine. I'm not working for you, right? But if I say, you got to trash the girder, then they'll, sorry, John. I mean, yeah, you're my friend, but this is what you should do. Right?
Try again.
Yeah, so I think I know they like that, and we're quick because we already have agreements in place, so to speak. Right. So if I'm trying to think of one, Minnesota had an issue with some T1 steel, and they shot an email out and talked to their bridge engineer, who I know well, and I said, I'd kind of like to see these, and he's like, you'd come up? I'm like, yeah, that's what we do.
That's what we do.
And so I flew up there like 2 days later and looked at it and helped them with retrofitting, right? And so PennDOT was a recent one, actually. I just went out there to look at something with a crack. Actually, that was more recent than Minnesota. They kind of run together, but...
You get all over, don't you?
We get all over, right? So we're coast to coast now, right? Because we have California and New York State. And I joke, Alaska is in for certain things, but they're probably going to join in general. Their finances are kind of weird, but
So you do a lot of training with S-BRITE, right?
we do.
So
Yeah.
you train anything from like bridge inspectors,
Yep,
all
to
the way through
designers.
bridge engineers,
Yeah,
or
yeah. So the course next week is going to be 2 days of designing steel bridges for fatigue and fracture. So that'll be all engineers and consultants. Now consultants pay, right? I mean, we generate a little revenue back to improve the courses and stuff. But a partner state, it's included. And then they want us to do a special day. We do a separate class for inspectors on inspection issues, but and it's all steel, right? So it's not like concrete or anything. But they're like, well, how about a 1 day? Is there something you can do in 1 day, like a little refresher thing? Like, yeah. So we give them the course menu, the course topics, and treat it like a sushi menu. Pick what you want. And so we're going to do an extra day for that. So yeah, quite a bit. We've been working closely with NDOT, trying to get one of our courses to be an approved equivalent to NHI course. That was on Federal Highway's suggestion because they'd say ours is better, but it's federal government stuff. So it's been like 3 years, 2.5. I mean, it's unfortunate, right?
welcome to the jungle.
Yeah, and I can't point it like it's this person's fault. It's just all the challenges and changes. It just is. Yeah. So everybody's trying. Once that gets approved, which I've said now for like 3 years, but once that gets approved, which I'm optimistic.
Hopefully it gets approved before you retire.
Before I retire, yeah. That's going to be a game changer because I got 27 states that email me. Every state seems to me email me once a week. Like not all 27, but is it approved yet? Is it approved yet? Because your course is better. And if you think about it, at the Bridge Center we have tons of steel components, right? So we go out and look at the thing and say, this is what you're looking for here. When it's on the road, we either bring a whole trailer.
Yeah, I've seen the trailer.
I've
seen the trailer.
Yeah,
yes.
right. We bring a whole trailer of stuff with specimens, and so.
So this helps when you train, right? People actually see things
hands-on.
and can put their hands on it.
Yeah, yeah. Because that's how I learned, right? Remember I was saying about the bridge, right? I looked at that bridge, and I think that's one of the issues is that, when you want to show a problem in a slide, you show the problem that is the most obvious because it has to show up in the picture.
Right.
And that's the 1 of 100, right? Or you did something to make it look really good. And that's not how most of the cracks are, or corrosion damage, or just whatever it is. Weird details. And when you're standing there at the girder and you're trying to explain stress flow and stuff, it clicks, whether they're high school educated bridge inspectors, not PhDs or something like that, or they are PhDs, right? Trying to reason through that. So the center has been an incredibly unique thing. So unique that, UT Austin copied it, right? They're doing one with concrete.
Right.
And I applaud them. I think that's kind of neat. I wish people would have done it here, but they try to do a concrete version of it.
Well, it kind of makes sense, right? We do have an aging infrastructure in the United States.
Yep.
You can only replace that so fast. Even if you had all the money in the world,
you couldn't.
Physically, you
couldn't do it.
Yeah, you can only do things so fast. So, you're really a steel bridge person.
Yeah.
But now you've kind of with S-BRITE, you've kind of moved into workforce development, right? You're training people.
Yeah.
You're trying to. Yeah. You're trying to train anywhere from somebody who's just come on. We'll take a local agency, right? That I'm involved with. So local agency hires somebody, say we want you to be a bridge inspector for us.
Yeah.
But they got to go through.
Well, there's nothing really. There is no training.
Well, there isn't until.
Hopefully, what we can work on. Yeah.
Right.
So there's two prongs to what. Yeah. The other thing I've seen, and this is again an S-BRITE thing, is that, and being in the industry for a long time now, and this could be surprising to most. I think policy people would be surprised at this, but nobody teaches bridge engineering at universities.
Yeah,
nobody
that always boggles my mind.
Yeah,
they teach vertical.
Vertical, right? We do buildings,
right.
and traditionally that's what I've taught. And that's just where everything has been.
Because steel is steel, whether you put it in a building or a bridge, right?
Yeah. Except that's not really true, right?
It's not.
Yeah, and it is, but in the bridge world, again, we have to inspect our structures. So you have to, like something silly, but you have to design them so they're inspectable.
Yeah, you have to be able to get to all the connections
detailing
and things,
for inspectability, we call it, right? we have the limit state of fatigue. Repetitive loading buildings don't ever have that. How you detail so that you can even deal with fatigue. Like the quality of the work in bridges far exceeds buildings. Other than in seismic, there's a lot more attention to the quality. How you detail so it won't hold water and corrode, right? Like just a lot of stuff. That's just all on the nuts and bolts side. The loads are completely different, right? The codes are completely different. And so imagine you're an undergrad, you know nothing about any of it, and you teach everything about buildings, and then you go, boom, 2 volumes of bridge design stuff. They're at a loss. So consultants spend, 2 years getting somebody up to speed. I just think that's silly, right?
Yeah, so I'm just curious.
That's on the bachelor's type side.
Yeah, so I apologize for interrupting, but I'm curious. So like even here, you guys would teach or have taught for years, right, vertical steel.
Yeah, that's what I taught last semester.
Right, so you're teaching how to design steel, but it's typically from a building perspective.
Yeah, I use the building code.
Yes. At some point in that class, do you at least mention bridges? And hey, there is this thing called bridges.
Yeah, right? I do, right, because that's really what I'd rather be teaching in a way. And I always take like maybe 2 or 3 weeks and talk about fatigue and fracture, which probably there's 3 people, my other students who are out, right? There's maybe a couple people in the country who would do that, right? Because it is a little bit of a niche thing. But
so nobody goes to college, not at the bachelor's degree level, to become a bridge engineer.
No.
There's no such thing until
Rob
Connor thought it up, right?
Well, so I kind of felt like there's an opportunity and a void and a need, because I see the demand in the industry of how much infrastructure, you can't replace it all, right? And even if you had the money, the materials, and the contractors, you don't have the engineers to design it all. So the thought was, well, why doesn't anybody teach steel bridge engineering, steel bridge loading and analysis, concrete bridge, right? So, and so I, talking with the people I run with in the steel industry about this, American Institute of Steel Construction Fabricators, they were like, yeah, it stinks. And the problem is, then they come out and do stuff that, the way the fabricator would say it is like, well, we can't build that, or it's stupid. If somebody would explain some of this stuff to them ahead of time, even consultants, right, because they have that huge learning curve. And the university's not going to fund it, okay? I'll just leave it at that, but they're not. But the industry was very excited because they will benefit. And so I am proud to say of the steel industry, they've provided at Purdue a commitment of about $2.5 million for us to hire an instructor entirely dedicated to that, and hopefully a second. We can raise a little more, and we have alumni and folks kicking in for scholarships, because there's such a thing. Now we're trying to get it on the concrete side. Concrete does not appear to be as organized as steel. I know they're interested.
Probably a much broader industry.
Like one of steel's weaknesses, right? They'll say, is like every state has 3 pre-stress plants, right? Kind of joking, because they're everywhere, right? Shipping is different, all that stuff, right? It's not the same with steel fab. One of their weaknesses is there's 3 pre-stressors in every state, because how do you herd the cats, right? So for me, I can go to like 4 people who are the biggest steel bridge fabricators in the country, and they can provide good support.
Right.
There's not the equivalent of that I know of anyway in the concrete side. And so I've been working with them. Again, they're interested. I think they're trying to figure out how do we do it, to what level, because we're asking for a decent commitment to fund somebody's salary for 5 years. You know, it really, frankly, I think it needs to be something more legislative. Like the ROTC kind of stuff, because really who owns it is the government. And I believe that if you sat down with some policymakers and said, nobody teaches any of that. I think people think we do. Right. People think.
Well, they just think steel.
Steel, or structural.
If you take a steel class, right, you're good.
You're going to get that, and we don't. And that's what I'm trying to change, is that we would be, the first place doing that.
I think what lay people don't understand is those 2 books of code that you just talked about dropping on the table, right?
Yeah.
There's a lot of stuff in those.
Yeah.
And it's not difficult.
No.
But to understand and know it is.
And it's just the industry thing, right? Technically, right, you could probably, after like undergrad mechanics and physics, you could be an engineer.
Well,
you have the basics, right? Yeah. So I could be an aeronautics or whatever, and but we know that doesn't really work, right? You got to go further, right? Okay, well, when you start breaking into structures, buildings are different. It's just a different industry, right? The lingo, just how you do everything. And so there's no program for that. So yeah, hopefully we can assist with that. But probably where there's even a potentially bigger void is the one you started talking about on the inspection side.
Right.
So you're a young person, you come out of high school, you're like, I don't want to go to school for 4 years. Well, what are your choices if you want to get an education? Well, you'll go to be an electrician, HVAC, hair
Plumber.
technician, plumber, right? You know, and one of the people that I've been talking to about this, she was telling me, she goes, when I go get my nails done, the person doing that is licensed. When I get my hair colored, it's a she.
Yes.
She's like, she's licensed. You're telling me we're going to build the Francis Key Scott Bridge for like $4 billion, and that inspector doesn't have to have any training? I'm like, no, they don't. Team leaders have to have what's called a 2-week course, and maybe a PE or something like that. But the average inspector technically doesn't have to have anything by law.
That's kind of frightening.
It is, right? And you think, I wonder why we have issues sometimes, right? And again, they're all trying to do the best they can, but where I see it is there's no career path, right? Like, well, what do I want? I'd love to get into infrastructure. Oh, well, you can be a mason, you can be an electrician. There's no like bridge inspection technology equivalent, right? A 2-year degree in that would help you with all the NBI, National Bridge Inspection Standard, all that kind of stuff. And so we've talked to some states, and they're like, we're dying, we're starving for people.
Right.
And
I got to guess that's true of most states.
it is. And so that's where now through a pool to fund study, I've talked to NDOT, and they're willing to lead it. And we already have about 10 or 12 states who are like, we would kick in to develop, to research, and I say research loosely, I mean really to figure out what that curriculum is and what is that course material. And the way I'd like to see it happen is that where it could be appealing is we would cover the technical stuff, because one thing the states are and federal highway are very big on, and I agree with it, is consistency, right? For the inspector, like when you do it, here's what the law says, here's what these manuals say, consistency. So we would handle that part. But if you need like physics or chemistry or something for a 2-year degree, and I don't know what all goes into that, you could take that at Utah State, but then online you could take our courses. And then that would be your, certificate or something. And it would speed the process then to become a team leader in these different things. But at a minimum, it would give a career path, right? Something if you kind of wanted to do it. And the other thing is, I always say whether it's the bridge engineering education, the BS side, or this program, I would bet you there's probably two young people in every state who would like to be a bridge engineer. Well, that's 100. That's not a bad sized class, right? So I think if you just play the numbers, I think there would be demand there. And at Purdue, we get students from all over the country. So if we can have some scholarships, and in this other thing for the inspectors, we plan on doing some scholarships for that. I think I'm optimistic,
So from an inspector standpoint, though, say you come in, I'm 18, I just graduated from high school, and I'm thinking, I really want to, I'm like Rob Connor. I saw bridges one time, or I walked across the Brooklyn Bridge or the Golden Gate Bridge, and since I was a little kid, I love bridges, and I want to work on bridges.
Yeah.
I'm not sure I really want to go to college.
Yeah.
But maybe I could get a job as an inspector.
Yeah.
So Rob Connor's got a program, or putting one together, that could basically get you through like a 2-year program.
Yeah. And you could take your other courses though somewhere else, right?
Right.
And then you would transfer these in, because I think most people would accept that. And I need to work with our local community colleges. I need to reach out to them. There's a couple questions within Purdue I got to get straightened out right now, but not big ones. But I think you would partner then with some other community colleges to do like the beta version of it.
Yeah. So I'm 18. I think, hey, this is a great way. I'm going to become a bridge inspector and be a team leader.
Yeah.
And so I go through this 2-year program, and maybe I do that while I'm working.
Yeah.
Right.
Yeah.
So I've gotten a job with a DOT or whatever, or some.
Well, then they're reimbursing part of it
Yeah.
or something. Yeah.
And I do this, and it's somewhere along the line, now I'm 21 or 22. I've been doing this several years. I think, I really enjoy this. I'd really like to design bridges.
Yeah.
I need to get a bachelor's degree.
Yeah.
And all those things that you've done up to that point really feed into that, do they not?
They should. I don't.
I mean, you get a 2-year college degree.
Usually that's then your springboard, right?
Right.
If you want to continue. Yeah. And the owners actually kind of like that, what some have said, and I thought, again, you talk to people and you're like, oh, that's a neat idea. I never thought of that, right? But the idea that they're existing inspectors who never really had good training, right? They took this 2-week course and whatnot, that they would go into a program like this with the idea, maybe they already have an associate's degree or something, but they would go into it and it would springboard them then to become the manager or the team, that's further down the road for a longer career path. So again, we're looking at two halves to it. One would be if you wanted to do some kind of associates thing where you work with another school, or you just give a certificate, right? So maybe you're already inspecting bridges for Nebraska, and you've done the one training thing, but to kind of help you in your career development within the job, you could take maybe these 3 courses and you get a certificate of something. You take 3 more, you get it. And there's a lot of different ways, right, you can help. So maybe somebody's been doing it in the inspection for 15 years, but they want to up their game kind of thing.
Well, I mean, if you're an employer of people, you like those as well. We have, at LTAP, we have a lot of local agencies who will give pay bumps, depending on what courses you've been through at LTAP, right?
Yeah. But there's no path for that now, right?
Yeah.
So, but that idea, and again, this was one when this person told me about my hairstylist has to be licensed.
Yes.
I think if you kind of related that to the general public, can you compare that when you're sitting over the Ohio on a bridge on a cold January night, thinking that your hair person was licensed, but the person doing the inspection didn't have? Now again, there are licensed engineers who would be team lead, whatnot, but
right.
It does just seem a little inconsistent, right? In terms of that's how regulated that is, and whatnot. So.
Well, I like the whole thing. I mean, you're talking about. There's a lot to unpack in there. For one, it's a need that the industry has, right? We need better inspection, better inspectors, people that are more qualified. Not that we're not doing anything wrong.
No.
But it could be done better, right?
Yeah.
I mean, there are different techniques and things that could be upgraded.
And the other reason for it is, again, the infrastructure. When the NBI came, the bridge inspection stuff, right, came in the 70s after the Silver Bridge collapse. Like I said, much of the infrastructure, like on the interstates, was newer. Right. So how you treat that? It's kind of like you're a doctor and all your patients are 16 to 30 years old.
And now your patients are geriatric.
Yeah, but you also have the 16-year-olds, right?
Yeah.
And 18-year-olds, right? So you got to manage this different range of people with different problems. And so how you treat that? Well, your people who do it then either have to have better skills to manage that. And some of the things we now have in the NBI based on work that we did here and another university we collaborated with, Glenn Washer out in Missouri, on the risk-based, right, where you actually look at the specific, just like you would with healthcare.
From a risk-based standpoint.
Well, you need, but that's what you want to, you kind of need a better workforce. Because if you're going to do it on risk, they need to understand what went into that risk, right, and what that even means. And so that is the reason to up the game of the individuals inspecting, because the inventory is so diverse now, and the way you're going to handle them to be safe is a little more rigorous than, oh, it's calendar-based, it's Tuesday, I have to go look, right?
From a risk-based standpoint, certain types of bridges, there's more risk involved.
There's more risk, right?
So you're going to go out and inspect them more frequently.
Yeah, or more in depth or whatever, right? And risk is 2 things. Risk is likelihood of the event and consequence of the event, right? So if you think about flying, right, the wing coming off, the consequences are catastrophically high, right? So it's high risk. Well, no, because the likelihood of the event is minuscule and deemed to be so small that the risk of flying across the Atlantic is low, right? Because so that those concepts and how you approach inspection and manage it in infrastructure, right? Because that's really what you're trying to do. You kind of have to bring up the level of the people managing it, but really the boots on the ground have to have an understanding of that too. So.
Yeah, that is. We are building a lot of new bridges, right? A lot of bridges are being replaced all the time. It's a constant procedure.
Yeah.
But still, a lot of the infrastructure has gotten older in the U.S., a lot of the bridge infrastructure, and, somebody's got to keep an eye on that.
Yeah. Yeah. The average age, the number you'll hear, which I think it's probably older than this now, but the average age of a steel bridge in the U.S. is in that 50 to 60-year-old. And just whenever the highway people are like, oh gosh, I just say, well, just be glad you're not the railroads. Because one of my friends, Steve Dick, would say, like, it's the rule of 75s. Like 75% of the railroad bridges are 75 years old or older or something like that. And so they even have an older infrastructure. And all this pays off for that, right? When you're doing the bridge engineering training, we'll talk about railroad inspection. You have to inspect railroad bridges, right? So it is a little overwhelming, though, if you just think about that, right? Say on the railroads, like, they're riding on the conservatism of their great-grandfathers, 1900 bridges still, because that's when railroads had the...
You do work with the railroad some, don't you?
Yeah, quite a bit, yeah. Well, when I was in New Orleans, there was 2 meetings. There was the Steel Bridge ARIMA Committee, Committee 15, who does the steel bridge specs, and then for convenience, we overlapped. So that meeting ended, and literally I went to a different hotel, and then we started the highway bridge specification, AASHTO discussions. And they're completely different groups for the most part. There's some people who overlap. But the railroad stuff is fun because railroads are neat,
Yeah, we were kids, right?
Everybody likes trains.
We want a train set.
Yeah. It's funny on the railroad.
I never got one, by the way.
Oh, sorry to hear that.
Yeah. Probably why I'm like I am.
Yeah. We have 5 railroad bridges. I think it's 5 or 6 down at S-BRITE. Complete
Really?
Bridges, yeah. But the funny thing is like on the highway side, they'll talk about accelerated bridge construction. Get in, get out, stay out, right? Do it quick.
Yeah, they say it all the time.
They say it all the time, right? And then you talk to a railroader and they just laugh because they were doing that in 1905 because, you can't steer around the bridge. I can't take County Road 300 to make a left to go. If that bridge is out, it's turning a valve off, right?
Right, if the railroad's out.
Right, and so to them, accelerated, how else will you do it?
Well, it starts to really eat into their economy, right?
Exactly.
I mean, they can't, if you're DOT and you have to shut a road down, it's going to affect the economy some.
Yeah.
But it just really is it just has hassle for everybody.
Yeah.
When it comes to trains, if you have to shut a road down.
You're backing up trains for 1,000 miles, man.
Yeah, all of a sudden you can't, that's how you make your money is moving goods across that.
Yeah, you can't just steer around it.
No, right, there's just not, oh, let's just go that way instead.
Yep, and so you start backing up trains and produce rotting on trains. There's a lot to it, right? Yeah. I've heard some really cool stories about like, engineers will be, well, it's cheaper if we fix it and we have track outages every night for 6 months. And, the guy who knows the money says, well, what if you can't get it done one night? That kind of thing. And, well, we would need another day or two. Like, if we stop that train that has, I don't know, pineapples on it, there's $25 million on that train. If they go bad, put a new bridge in. Slide it in one night kind of stuff. They're probably extreme stories. But
So we're going to go back just for a second. So my understanding is that you really have started your bridge program at Purdue,
so the bridge
right?
program is running on the undergrad and grad side. Yeah, we brought in...
and I don't mean any offense, but I haven't seen a lot about it.
So, yeah, so Dr. Frank Bonaceri, he did his PhD here about 6-7 years ago. We were able to bring him back.
Mm-hmm.
Passionate about this, talented. He's written AASHTO specs and stuff. So I really couldn't have gotten a better person, I think, because I was talking to him and I said, yeah, I can never get a guy like you. And he's like, maybe you could, And, honestly, the reason is he'd been out, not 30 years or anything like that, but he could see it. He's like, there's no training. Yeah. Like, we have to start doing something as an industry because then who's going to go into it? Because, again, competition, competing with SpaceX, Tesla, AI, all the sexy stuff, right? If we don't do something as an industry to lure people in and say this is a good thing to do, motorsports, whatever it is. So last fall of 25, we did our first 2 courses on like kind of intro to analysis loading because it's different on bridges. Mm-hmm. And then he did a grad course on steel bridges. Then this spring, the undergrad, so the typical undergrad steel design, there's the parallel version that's the bridge focus using the AASHTO code. And here's how you do everything you would do here. Here's how the bridge guys do it. And then a course on trusses and truss connections, which you would never see in a steel class. And then we're going to do another one in the fall that would probably be on curved bridges, which are all steel. So yeah, in terms of advertisement, I mean, the flyers are up around the building. There's been some announcements on it. I think we need to get better at getting the word out around the country, frankly. And then this fall, the grad courses, the plan is to have them online. So Frank's working with getting space to do them online. We wanted to go through them once to kind of get some of the bugs out. Because again, the curriculum does not exist.
Right.
At most you'd get at another university would be the token bridge class where you cover everything in one class, at most. And so this is really building a curriculum. And so when we did our advertisement through Purdue, it got a little buzz. But then when AISC, who was the big sponsor, they released it. They do it, boom, across the country kind of thing. And I started getting emails, and Frank did, and we were getting them from around the world. Like, how do I sign up? How do I get these classes? So that was kind of cool.
So there are a lot of people that want to be bridge engineers,
or existing and who want training.
Right.
Because imagine, you come out of school and you're working for a bridge firm. You're learning all this stuff. Well, what are you going to do? Take another course in buildings?
It's like drinking from a fire hose to use an overused.
Well, yeah, that's true. But I mean, like, even if you want to take graduate courses, what are you going to take? Another buildings class? You're working at a bridge firm.
Right.
So.
Well, there's a lot that can be done.
Yeah.
So in the 5 to 10 minutes we have left, let's just talk a little bit about the Center for Aging Infrastructure.
Sure. Things
that go on down there, possibilities. I know that you and I have talked before about different things that could be done.
It's 20 acres.
You're right.
So if you're at a university around the country, right, land is gold. And so I joke, how we convinced the Board of Trustees to give us the 20 acres. I'd like to think it's because they had vision. They thought this was a great opportunity. We've developed 10. There's 10 left. So that's for everybody, right? So a big collaborator, Brandon Folk on the construction side, right? I mean, if you think about what you'd want those young people to be learning about building things, cranes, trenching, you can't do that on campus. You'll really get in trouble, right? So he's got this incredible area he's developing and developing more to do these things. They were just down there driving sheet pile to do stuff, and that's not my area. My job is to facilitate it, right? How can we help you get this done? Luna's been down there doing stuff, right? You guys, I think, have done stuff down there at LTAP, right? Marika's been down there doing soil stabilization, right? Different people can use that facility for those bigger outdoor, where you need a big space. You'd like to do it for a long time in the environment. Amit's done big fire tests down there. I mean, like, just full girders burning them, right? Like under heat and fire impact, fire simulation, not simulation, it's a fire. So the opportunity to do large scale things, either that you need to do them outdoors or you need the space for, I don't think there's anything like it in the world. And then let alone S-BRITE, right? Like what we're doing.
Right.
And what's cool is, like, if you want to, like, some people are doing things with drones, and we've done some stuff with drones, but if you want to, fly drones around bridges, well, now you have to call an owner, traffic control, what if I crash it into people and I need the cost of traffic control, maybe fall protection. Our bridges you can walk right up to. Right. So other people have come down and flown drones, or from other universities, right? And so it's a really neat facility that, we have some modest use fees. We got to pay to get the grass cut or keep the lights on, so to speak.
Well, I mean, you mentioned like some of the stuff that construction does, Brandon. I think it's safe. We've talked about before that's a facility that could really be expanded into a huge workforce development kind of a thing, right?
Yeah.
Where you could teach people how we drive piles, or you could teach people how you grade, soil in order to get what you want, how you compact properly, all those different things.
Yeah.
All those things exist, and there's a huge need in the infrastructure construction industry.
Absolutely.
Right.
Yeah.
Whether it's vertical or horizontal or whatever it is.
Yeah. We have like 150 foot span through truss down there in pieces that was saved, and INDOT gave it to us because they have to keep it for a while. And Brandon and I have been brainstorming, like, well, why don't you, if they can get some people to help support this, like, it might take 3 years. Let the students figure out how to pick the steel, erect it, basically rebuild the bridge.
Right.
And then when you're done, the next group start taking it down safely. Because there's all those calcs and wind load on the, you could really get into this, right? And that would dovetail with the bridge side. Because when I talk about the bridge program, the people I talk with, especially, the Walsh, the Kiewicz, those kinds of folks, Kramer, they're like, it would be great if you could teach about the construction side and how to erect steel or concrete or whatever it is. So there's such a natural collaboration there on the bridge side. But again, the funding is, okay, I'm all for hiring this person.
Right.
But we're not going to get a hard line through the college for that, right?
No.
And so it's going to really be industry. And again, I think it'd be nice if there was other funding to help support that. I will say on the steel side, but the whole program, our goal, when the people provided this support, in the steel industry, the natural question from some of the fabricators was, well, why not in my state? Why doesn't my university? Why wouldn't I give it to them? And my joking answer, but serious, was like, because I'm the guy standing in front of you.
Right.
We're the ones who are stepping up to try to do this.
We can do it.
We can do it. But then I would quickly follow that with, but anything we create, we will give away. Like, the curriculum doesn't exist, even the material. If your university in such and such state says, we're going to hire 3 faculty to do this, we're going to copy you, great.
Here's the slide.
Here
Here's
you
the slide
go.
decks. These
Yeah,
are
like,
the material we're teaching.
I mean,
These are the classes.
Yeah, because I feel like industry paid for it. Industry should get it. And it's there, they would never be as good as us at it. And,
Well, who would be, right?
And we have S-BRITE and everything. But my point is, like, we do want to see this grow, too.
Well, it's good. I always tell people when it comes to civil engineering, right?
Yeah.
That we do, at least from a construction or, from an infrastructure point of view, design is, you got to design things properly, right?
Yeah.
But you also have to understand materials.
Oh, yeah.
Because you have to have the right materials. I'll use the Titanic as a good example, right?
Yeah.
It had a problem with steel.
Oh, yeah, yeah.
And construction.
Yep.
If you don't get construction right, and I used to, especially when I'm teaching the students in a design class, those are the 3 things that we worry about.
Yeah.
You get one of those wrong, you might be okay.
Yeah.
You mess up 2 of those, you're gonna have a problem.
Yeah, yeah. And the materials one is another area where I'd like to see us have more, especially on the metals.
Right.
Because nobody
a
really
better
teaches,
understanding of steel as a
welding
material.
and all that kind of
Right.
stuff, and how it ties into, again, our applications. Because I think sometimes people don't see that, right? They'll say, oh, they could take a course in the materials department. Like, it doesn't do us any good. I mean, a good theory, right? Or maybe, phase
Well, to give you a
diagrams.
good understanding of basic molecular structure or something,
Yeah,
right?
but what we do and our issues,
Could be different.
it is.
Well, we'll have to have you come back in a few years or something.
Let's
to tell
hope.
us.
Let's hope. Yeah.
It sounds like a great program. I'm really excited.
Now we're
about
excited about it too. We appreciate. Again, the industry. I just am amazed that they trusted us. Right. I mean, that's a lot of money to trust us with, as well as the people who are providing support in scholarships, alumni, and the big master plan is to have a building down there. Right. There's plans together now and trying to raise funds for that. So we would. If we can pull this off, especially if we can get the concrete support, which is critical, it'll be a unique program in the world,
Well, I wish you all the luck in the world.
Yeah.
I guess my challenge to you is to get it done and up and running, everything completely before I retire.
Okay. So another 15 years.
That's
That's pretty generous, John. Thanks.
I doubt it'll be that long. No.
Okay.
But I like to see it.
Yeah.
Because it's really needed. At least in my opinion. Right?
Yeah, and that's where, again, that's where I think if maybe policy people were more aware of the fact that it doesn't exist,
Right.
that they might see the need, like, oh, we thought that was all getting done by you guys, kind of thing. I believe that, right?
Lack of visibility.
Lack of visibility, yeah. So how do we get, this is one way, right? This is good. And we would invite anybody who wants to come and see S-BRITE, let us know, or talk more about it. Happy to chat with them, because I think it's definitely needed. It's all good. It's rubber meets the road. And, it's not, sometimes we do research and it's kind of like out there. This isn't that. This is how do we help the workforce today, right? Frank is teaching courses today that are going to help, right? So.
All right. Well, all the luck in the world.
Thanks, John.
To you. I hope that everything
Appreciate
works
the
out.
opportunity to visit with you.
No problem. Thanks a lot for being here.
You bet. Appreciate the invitation. Happy to come back.